This is the table of application procedure for impervious tagging system. We started for this PE sheet, but unexpectedly we came across this GD1 MAT 015. It is for Corroprene 70 synthetic rubber elastomer sheet. It is used in both sewerage and this stormwater, where the pipe is passing through the concrete phase. So these are the two drawings, and this is the area where it is provided. So this sheet we are mentioning. So we can see in this one word file Q04 how neoprene rubber and resin bonding are supplied together. We can see there. So neoprene rubber provides flexibility and waterproofing for joints, and grid bonding is gives shear resistance to prevent pipe movement. It seals the joints against infiltration, but the grid bonded epoxy anchors the pipe to the structure. So these are the two applications. So neoprene rubber, this one, but this MAT 015 gives neoprene rubber details. This is Corroprene rubber sheet. This is 70.5. This is the hardness, short hardness value. So what is short hardness value? So we will discuss what is short hardness. It is in the Q04 photo. 04 short hardness photo. So this one actually short hardness. It's a measure of materials resistant to indentation. It is commonly used for rubber and other flexible materials, and its range is 60 to 70 shore. Some commercial grades are there. It provides a good balance of flexibility and durability. So 60, for example, 60 shore neoprene is known for its durability and ability to absorb shock and noise. So it is available from 40 to 80 grade, and short hardness scale ranges from 0 to 100, higher numbers indicating greater resistance to indentation. So softer 30A rubber, it will be suitable for molds with intricate decals, while 70 A rubber might be suitable for molds of flat details. So that is short hardness. So we are using as per we'll check the MAR sheet for the details of further neoprene rubber. So this is the specification. It is in our GC2 sewerage specification, clause 318. Here neoprene rubber shall be a short hardness of 35 to 55. It shall be wrapped. It is wrapped separate in 10 meters long rolls, 10 thick, 100 wide. It shall be supplied in flows to acid bags and other this one. So that is the details, specification details. Now we will see the drawing. So it is mentioned in 4719, where its properties are specially mentioned. It is a specific gravity, hardness, and so 70. Hardness is 70 plus or minus 5. Shore A, that is the hardness. So this one is provided in the specification, and and the 100 thick also mentioned. See, for example, here. So this neoprene rubber, as per our specification, is 10 thick. This is 1 centimeter thick, and when it is provided, it should be provided throughout the width of a wall, but is limited to 50 or 100 and when it is touching a liquid, a sealant groove should be provided with a sealant, and hardness is 70 plus or minus 5 is mentioned. So that is the details. Now we will go for the drawing. In both sewerage and stormwater, it is mentioned. We will see the form water drawing. Here, this area, this is we are providing this neoprene rubber, and this 10 thick, and in the sewerage drawing also it is mentioned. Yeah. So that is for the neoprene rubber details. Now it's a requirement testing, everything we'll discuss now. So this company is Corrotech, and brand name is Corroprene synthetic rubber sheet. It is a Corroprene 70 plus or minus 5 synthetic elastomer sheet, and it is non-cracking, heat resistant, chemical resistant, and typical uses is to protect a wrap pipe whenever it is passes through a rigid concrete face or structure. It prevents stress concentration, resulting in a possible fraction of the pipe of the concrete face. So this is why it is provided. It is a protective wrap tape. And we will now discuss the application, how it is applied. Application is not correctly mentioned here. It is just wrapping with this tape only. So now we will discuss grid bonding. So it is not grid bonding, MAR not presented in this submitted register. So we will go for the deep seek to know more about grid bonding and how it is applied. So grid bonding is applied like this: neoprene seal for water tightness plus a grid bonding epoxy at pipe structure interface. What are the materials of grid bonding? Epoxy grid coating material and silica sand or carborundum material. It is for surface roughening, and grid bonding coating is for shear resistance. When to use grid bonding, we use neoprene alone. Use grid bonding when the shear loads are high, like thrust blocks, slopes, etc. Pipes are sleeved and rehabilitated, need mechanical grip. Use neoprene alone when the only for water tightness or flexibility is needed. Straight trundle pipelines. So this is the grid bonding and the neoprene. This will copy and paste in the Q04. Then it will be more easy. So also we need to add here the how how we are testing this shore hardness. So it's a measure of resistance to indentation. We are using an instrument called durometer. It have a spring load indenter. A sharpened indenter means a sharp steel point. It has a scale also. It displays the hardness value. So indenter is pressed against the material surface, and the depth of penetration is translated into hardness value. Two kinds of shore values are there: shore A and shore B. It is shore A is for softer materials like rubber, and shore D is for harder materials like plastic. So its limitations are its relative measure, and it does not directly correlate with other properties like strength or wear resistance. So So now we will discuss about the PE sheet 1000 gauge. It is it is as per this table 7.16. It is provided under the blinding concrete. It is there for all. Here also stormwater drain. See, this is there. Stormwater manhole, stormwater chamber also. It is provided. See, PE sheeted formation is mentioned. Everywhere, wherever concrete is starting for before blinding, it is provided. So, with specification and sewer manholes also, it is PV sheet under the blinding is there. So, 1000 gauge polythene sheet is there. What is this? It is based on which system actually? It should be system M or what that we have to discuss. So in this page 391 it is mentioned system M. It is a rubberized bitumen emulsion plus a PE sheet on top as specified in 718. So we'll go for 718. 718 is for 718 it is mentioned the rubberized bitumen emulsion and system M is for this one. Polythene sheet we will check in the MA. So in the MAR it is not submitted for, so we will check details in the table itself only. So in 7111 it is high density polyethylene protection sheet. It says polythene sheet 1000 gauge heavy duty, minimum thickness is 250 microns. That's all. So it is clearly mentioned it is 1000 gauge polythene sheet, one layer, and PE sheet 1000 gauge 250 micron to be placed on the formation. It is for protecting actually the blinding concrete. It is provided under the blinding. So this after providing this 1000 gauge polythene sheet, we'll go for blinding. This blinding is a class C concrete blinding. So what is class C blinding and what is the thickness? Thickness is 75 mm. It is mentioned here. Now for what is class C concrete. So we are discussing blinding concrete class. It is as per C15, that is class C is mentioned, but the 20 distinct is 15, whereas our new specification 129 of 734 it is coming this plain cement concrete for blinding minimum class is 42.5. So why is it so that we this is say plain cement concrete under blinding under structural concrete? It is mentioned. So there is a conflict. Anyway, for the when you are mentioning class C, I think should follow 28 C15 concrete we should use. Now we have to discuss the waterproofing. Waterproofing was already discussed in the previous video, Q04 R00 Manhole types type 2, 17.33. Here we are explained we are using how we are using polyprime SB solvent based bitumen primer and B2 chip XL 2.1 mm, and over that the B2 board for the for our sewerage and stormwater manholes. Now we will discuss how it is applied with the detailed specification. Here in page 379 we have again this table. In this table we have a system called T1 plus T2 plus T3 plus T4. This one is for this structural concrete, like buried concrete extends surface in contact with soil and water for major structures. So this is the combination of the waterproofing system. In this, for the manholes, what we are having here is T1 plus 3, T3 plus T5. Um, uh, T1 system primer, T3 and T5. This T1 is a solvent bituminous primer. T3 self-adhesive bituminous membrane cross-laminated with the white PE at top. And T5 is a self-adhesive type of bituminous protection board as specified. This 3 mm thick. This is for minor structures manholes and over the blinding. Also, we cannot hear this T2 membrane. It is not shown in the manhole. Why? This T2 is a self-adhesive type SPS modified bitumen. So, non-reinforced membrane. So, we need to find the difference between this cross-laminated T2 and TT membrane system. Okay. So, our combination for this one, the waterproofing over here, waterproofing tank detail 705. This waterproofing actually is composed of this system T1, T3 plus T5, T1, T3 and T5. T1 is the bituminous primer, that is polyprime SD, we discussed. Then T3 self-adhesive member cross-laminated with a white PE sheet at the top. Then the protection board, 6 mm. Here in the infraproject we have put this bituminous pole protection 6 mm thick and 2.1 mm 2.1 mm self-adhesive cross-laminated PE sheet. But we need to check actually. Now, so the question is why we used protection board 6 mm thick. It may be because this is a standard specification and the specification of this made from this specification for the infrastructure is mentioning 6 mm or because maybe for additional protection. Anyway, what we are used is cross-laminated polythene sheet 2.1 mm and between primer SV prime for Hengen polybit. So T1, T3 and T5. And we have explained here what is the difference between T2 and T3. So this non-reinforced between and between the membrane, reinforced membrane and the cross-laminated with the white PE at the top. So what is this difference? This difference is mentioned here clearly. Key difference between this one is this is composer and the structure. Former is simpler, non-reinforced than the membrane. Later incorporates a cross-laminated HDPE film layer for added strength and puncture resistance. Also for UV protection and reflects sunlight and lowering surface temperatures. What is SBS? That is this styrene, butadiene, styrene. That is its SBS full form. Both are SBS modified bituminous layer applied directly to the substrate. Both are this mentioned here. Both are self-adhesive and uses SBS modified bitumen for waterproofing. Cross-laminated and the second layer provides superior mechanical properties and UV resistance. It is more durable, versatile option for certain applications, particularly exposed to. But we are having this aggressive environment, so that's why we are putting this cross-laminated. Choice between two depends upon the specific products. That's the thing. It is already saved here as a save as. It is already saved as waterproofing membrane. Okay. So now, so this is the waterproofing system we discussed. Now we have to go for okay. What is this sweep blast? That also we need to see sweep blast. Sweep blast mentioned there. Yeah. Yeah. Sweep blast. Sweep blast. It is in page 388. Is sweep blasted with a non-metallic mineral aggressive to achieve a minimum surface roughness of 100 micron on concrete. Seed blasting is a this one we have to adapt to sweep blasting actually instead of grid blasting in Mirfa, because grid blasting is not meant for concrete the protractor wise, and that is very true. But they had to employ the seed blasting because we required a surface roughness of 100 micron on concrete. That's why it was not and it is with a non-metallic mineral aggressive. So seed blasting we have to note it on perfectly here. Okay. Seed blasting we need to um, we need to have employed in Mirka instead of grid blasting. So this is the main point. Under micron, non-metallic mineral abrasive. Okay. So now we will discuss Screed in this above the waterproofing, above the blinding and the waterproofing. So in DM standard details, it is provided 25 Screed concrete. So this Screed is can be given as per the sewerage specification or MIRFA specification. The sewerage specification we will discuss now. So in this volume 2 specification, page 448, the Screed is given. Actually, Screed is so thickness is 25 to 75 is mentioned, but in the DM standards drawing it is 25 Screed only. Anyway, this is the mix is a 1:4 ratio, cement with the sharp sand mix, and with very little added, with little water added. So that is the sewerage specification. Now we look into ready mix concrete MIR in a MIRFA. That is this one. Its document number is 20190502 in the MIR folder of MIRFA. Here, this is the 10 mm 10 coarse aggregate 0 to 5 fresh sand aggregate, rule sand also provided. So this is the weight. MSRC, this is 280 kg. This is a screen design. This one and we are also using Sika Plus for 400. So this is in the page number 10 of 17 concrete mix design protection screed. So this is the MIR. So now we have discussed the Screed. Now we will discuss the base slab. So here in this sewerage manhole table, there is a base slab thickness is given, starting from 225 to 500. Now we need up to type number 5, that is 400, 225, 250, 300, 350, 400. That is the base slab thickness. So A and B are 200, 225 and 250, 300, 350, 350. D and E have same base slab thickness. Sorry, 400. E and F have same base slab thickness, but 350, 300, 250, 250, 225. Okay, whatever it is. So this base slab thickness, it is coming as a rectangular, that we will see now. For sewerage manhole type special, we have base slab thickness of 225. Okay. For type A, the base slab thickness is 250. See this type A plan. This there is no rectangular base slab, only square, only circular for the type A. But when it comes to type B, the plan view we can see that there is a rectangular base slab. Okay, its thickness is 250 mm at the outlet 5. But when it comes here, 250 mm outlet 5. But here this area is completely filled with concrete, and we have a reinforcement also there, Y8 at 200 mm center to center. So we need to find out what is this Y8. This one. Okay. Finally, the starting from type B, all manhole have this rectangular base slab, and diameter. The steel reinforcement is Y8 at 200 center to center. Y8 reinforcement is 8 mm dia reinforcement at 200 center to center. That's the meaning. So that is Y8 at 200 center to center. So the list of next items are water soap, construction joints, rebate, approved sealer, chamber liner, TRP laminate, then the bending and haunching, bending and channeling, okay, granolithic flooring, epoxy coating if any, then laminate over joint, then waterproofing we already discussed. Then we have this cover slab opening, and this double triangle heavy duty DA cover and frame, class A concrete haunch. Why haunching is prepared, why provided, and extension rings, then 3 coats of rubberized bitumen emulsion is provided here for the haunch, etc. We will discuss.